And similarly, what's y bar equal to? It's equal to 1 divided by the mass m times the moment about the x-axis. You go, what's the moment about the x-axis? 1 over m times the delta integral of y times rho x, y. So everyone, I think it's pretty simple to remember this. When you do x bar, this is always going to have what letter? X. And when you do a y bar, this is going to have a what? A y. But don't forget, the first thing you're going to want to do is get the mass. So each time you do this, you've got to do 2 separate integrals. So think about it. When one problem could take, if you find the actual center mass to a lamina, it could take you upwards of 15 minutes to do the problem. Because you got to first find the mass, right? Then you got to get the x bar, you do this mathematics here. And then to get the y bar, you're going to do 1 divided by the mass, do this. That would involve a total of like 3 integrals that you're doing. If each one takes 5 minutes each, or if you're doing them all by hand, it could take 15 minutes, true? So I know sometimes it can be time consuming just to do these problems. So on that note, sometimes on the test, just expect this. I might just say, hey, can you just find the x bar, which would be the x coordinate of the center mass. And you better, when it's center mass, it should be roughly near the center of that lamina. If it's a circle, right near the center. It depends on the density though. The density does affect it. Okay? So let's try one. Can I erase performance? Everyone think they got it? That's just math, or sometimes I just go find the mass. Alright, remember this is the density function. Alright, here you go. Why can I erase this? Here you go, this will be quick. What's mass equal to? Double integral, rho, right? All over d for density. What's x bar? Divide out the mass, double integral
X rho, that's why.
x rho. And what's y bar? Divide out the mass, rho. Alright. Remember that rho is just the density, so they gotta somehow give it to you. Okay. Ellen, can you find this for me? What is the value of x bar? Of the center of mass which is, you know, x bar comma y bar of the lambda that has density rho of xy just equal to y, okay, and occupies the region. So here comes our region of integration for our lambda. Occupies the region bounded by y equals x squared, y equals 0, and x equals 2. Just find the value of x bar of the center of the mass of a lambda that has density rho xy equal to y and occupies the region bounded by this. So let's draw the picture first. Let's just image real quick. That's just a parabola, right? Go out 2 notches, and there's our lambda. So far, so good? Ooh, hey, we're not going polar, are we? That's not a disk, is it? See, the only time we go polar is if you're dealing with a portion of this. So we're going to stay Cartesian. We're going to stay in rectangular coordinates to this problem. All right. But you still notice double integrals. You can go polar if you got what? If your lambda is some portion of a disk or something, right? Cool. Okay. Don't we got to get the mass first, though? So what's mass? What's that? Double integral. You want to do dy dx?
Yeah.
Cool. Where's this go? That's the density, right? Meow. Dy dx. Who's the top? X squared. Who's the bottom? 0. Go from 0 to 2. And this will give us the mass. Can I split it up? I need to be clear. Can I split this up? You can never split it up if you got anything in terms of those limits of integration that isn't a numeral. Right? General. This is a general region. What's the integral of y with respect to y?
Y third, 1/3 y cube.
Ooh, y squared over 2, right?
Oh, this is y, but not y.
Yeah, I'm sorry, just a y. And now what I gotta substitute for that y? I gotta substitute x squared in for the y and then square it. So what does that become? Ooh, x to the 4th over 2. I'm gonna carry everything down. This is why we only do one of these, because you go, man, one of these could take a while just to get to the daggone x bar, right? I know. I just wanted you to see what I do in same thing on a test. I mean, I can have you find the x bar and the y bar, but if I did that, I would want you to have like a TI Inspire calculator, where you could actually what? Just have that, let that CAS work. Let it work for you. But in this case, you and I, we're limited with our TI-84s, TI-83s. We'll just find the y bar. What's that turn into?
16 over 2.
X to the 5 over 10, you plug in a 0 and a 2, 32 over, you get 32 over 10?
Mm-hmm.
So is this x bar? No, right? This is just the what? Oh good, so this is just the mass. So I'm going to go over here, we're going to do one more integral and we can find this x bar. Alright, so I'm going to say x bar equals 1 over the mass. So when I can divide this, what the heck is 1 over 32 over 10?
10 over 32.
So I'm going to write that like that. I'm going to write 1 over 32 over 10 is 10 over 32. Okay. 1 over the times, so I did the 1 over this. What letter do I need? Because they're saying x bar, so I'll put the automatic x. What goes next to the x? The row. What was row?
Y.
It's a y. And you okay if I do dy dx again? 0 to 2. But do you notice we have to rework this entire integral? It's the same limits of integration. I still just have, we have to do a whole new integral. Iterate. No shortcuts. What's the integral of xy with respect to y? xy squared over 2. What happens when you plug in your x squared? X to the 4 over 2 times that x. Now you got x to the 5th over 2. Correct? I want to make sure.
It was x. I thought the bound was x squared.
So the bound is x squared, and I got to plug the x squared into the y.
Oh, the y is squared.
And then I got that lonely x outside of it, making it now what? X to the 5th. So I'm going to cover that. And we're going to go from what? The integral from 0 to 2 of that. Well, before it came out to this, what's this become out to? What's that integral?
1, 12.
12. What the heck is 2 to the 6th? And look, I know you're going, Professor Measure, don't forget. What do I have in front of this?
10
I'm
over
not going to forget that 10 over 32 to multiply this. So 10 over 32 times this. And this will give you my x bar. What is 10 over 32 times 2 to the 6th over 12? 10 over 32 times 2 to the 6th over 12. What's all that simplified to? Is that 20 over 12? What's 20 over 12 reduced? 5/3. Remember, that's x bar. Now, let's double check this. Does that seem like a realistic answer? Look at that region. this went from 0 to 2, everyone, the average x value, is it somewhere between 0 and 2? Yeah, that number's about 1.6. Does that seem appropriate? It does, because the shaded region is more over here. Very good, so that's why I always double check it, so I don't get some bizarre answer like 5,000. And you're like, that's impossible. It's gotta be the average x. X bar is the average x, y bar is the average y over that region. It should be near the center. Cool, isn't that neat? And this can be used in terms of center mass. Do you have to do that in a physics class? I'm just curious. Anybody have to do this in physics? Okay, sometimes I know the students do that in physics. Hey, before you leave, there's one thing I wanted to talk about is this density. And my problem, what did I give it to you? Why? So, before you leave, sometimes, like in the practice set, they give you density in a sentence. And I didn't want it to confuse you, okay? And this problem is simple, I just gave you what? Why? So can I give you a couple examples before you leave? I'm not talking about solving the integral, just expressions of what they said. So try this one. What if they said this? The density is, I'm going to read this in words. So let's put E. What is this? The density, this is for some lambda, is, hold up, I got to find where I had these. All right, ready? Here's the first one. Equals the distance at any point on the lambda from the origin. What would you put for your math equation? Anybody know? Your density is, let me repeat it, the distance at any point on that lambda from the origin. So you need the distance formula in two-dimensional space. If it's from the origin, it's just what?
X.
X minus 0 squared plus, but I can simplify this. What do you get?
X squared plus y squared.
There you go. So and there you go. If you hear the wording what? The density equals the distance at any point from the origin. Use that for your density. Now I know you're looking at it like, ooh, that's complicated. Yeah, but is that going to be complicated if you go polar?
No.
If you go polar, that's just going to turn into the square root of what?
R.
R squared. You probably just turn to R. Very good. But don't forget your other R. Now couple more. What if they say this? I'll erase this. Because I saw this on the practice set. Ready? Your density equals the reciprocal of distance from the origin. What's the formula? There you go. Am I missing anything? Yeah, there you go. So Brad, very good, because it's 1 over that. Cool. Hey, the only other thing I saw, I didn't have this on the practice, but the problem in the book, it just said distance from the y-axis point. So if you had a lambda, let's say this was the lambda. The distance from the y-axis, wouldn't that just be a distance x?
Mm-hmm.
So if they said just distance from the y-axis, your density would be x. What if your density said just distance from the x-axis?
It will be y.
You're good. Hey, have a great weekend. Super job with this. Hey, next week I'll make sure we start doing the triple integrals. That's not yet. I just wanted to give you an idea of what was coming.